Kia ora team, and welcome to a tutorial for creating noughts and crosses with Python 3.4. So things that we're hoping to cover today, we're hoping to look at the UML diagrams that cover the classes that we'll be using. So we'll have a look at the attributes and the behavioral methods of those classes, as well as a little look at the pseudocode that will outline our program. So we're creating classes, creating objects from those classes, creating a GUI using tkinter or tkinter, however you want to pronounce it, and as a final kind of piece, we will bring it all together to create a noughts and crosses game, or tic-tac-toe if you happen to be American. Okay, so we're just going to have a little look at what our program will end up looking like. So here's my noughts and crosses. So if I click on a label, it changes to an X, and you can see it's now O's turn. And when I click on a label, it now changes to an O. Switch back to it's X's turn. X, O, X. I've got 3 in a row, and you can see it's displayed X has 1, and I can't access the game anymore. It's kind of switched off the game for me, locked it down. So that's what we're going to end up creating, and these things here are just labels. Yeah, they are really useful because they can display text, obviously, and we can update that text, but also they have events associated with them. We can test or kind of listen for an event, and when it's clicked, we can do an action based on that. So that's really, really useful, and that's what we'll be doing. Okay, so first thing is first, the planning. So these are the UML diagrams that I've drawn up. These are the things that I think we will need to use. So on the left-hand side, we have our board class. We have attributes that make up that board on the left-hand side. So we've got, you see the name of the attribute and then the type that it will be. So we've got a board frame for storing our little game in. We've got a list of squares. Because when we create squares, we need 9 squares for our noughts and crosses game, and we're going to store them in a list just so we can check through them when we want to check that our game's been won or not. We need a player turn to keep track of whose turn it is. We've got a game 1 boolean, just say game 1 equals false, and then when somebody wins the game, we can switch that to true and lock down the game. And we've got a little instruction label, which is a tkinter object, and it will just display whose turn it is and some information about the game and things like that. So that is the attributes board. Down here we've got the behavior, so that's the methods that the class has. So we've got a method to create the board, you'll see there, and moving downward we've got a few methods, and these are mainly what we call accessor methods. So they do things for us, or they return a value for us. So you'll see there that third one down, check player turn, it just returns an integer. So it just returns the value, of player turn. Yeah, just returns whose turn it is, essentially, which is quite useful. And so yeah, now on the right hand side we've got the same thing for the square, and these two diagrams, these two classes, sorry, they will access each other. So when I create a board, yeah, it actually starts creating square objects and adding these to the list. So it actually goes away and creates one of these objects. Okay, and then as we move through square and get to the behavior, we have this behavior called square clicked, which will actually go back to board to use some of its methods. And what we can use for that is this board object at the top. We need that board object. Okay, so when a square is clicked, it comes back and it accesses a few of these methods, and we need that board object to make that happen. So that's quite useful. Now you see we're using these access methods like I talked about. It's better than accessing these things directly. We don't want to access those variables, those attributes, directly from another class. We want to go through an accessor, so we don't want to access them directly. If we access them via an accessor method, it's just a little bit formalized, and we can keep track of the changes that we're making to our attributes, and we don't lose sight of what's happening, and we start to avoid bugs and issues further down the track. It's just good programming practice. So now that we've done our planning, we've had UML diagrams set up, we're going to jump into a bit of pseudocode. Now, pseudocode is a code-like language. It's when we write about what we want our program to do in something that kind of resembles code. Now, it can really closely resemble code, or it can be quite far away from resembling code, depending on what you need to do and how specific you want to be. So there's an example of pseudocode. So if student's grade is greater than 60, we're going to print passed, else we're going to print failed. And it's quite close to actual code, that example, but we can be further down the spectrum and away from actual code than that. Obviously, it's not actually going to run, it's not actual code, but it's close to it. It gives us a good idea. So we're going to write some pseudocode for our program. So first of all, we need to create a window for this thing, a system window for this thing to display in. So it will look like this, and it will be in that main section. We've seen that kind of thing before. It should be fairly familiar. Now we need to create the board, and we're going to use that root object, or we're going to pass that to the board class. Yeah, so we're going to create a board, and we're going to pass it that window. That window is going to be the parent of the board class. So everything that's going to be displayed in that board, or created with that board class, is going to go into that window that we just made. So heading into the board class, it's going to first of all create a frame inside to hold our game, to hold the noughts and crosses grid. And why that is useful is because if we want to, say, display a few buttons down below the game to actually control the interface, maybe change colors, or to restart a game, or to label the player names or something like that, if we've got those things down there, we can have a lot more control over where they are placed if we separate out the grid that controls the game, that 3x3 square, and the buttons. So we're going to put the 3x3 square inside a frame so it's nice and separate, and we can have our own formatting for any buttons that we want below. So that's why we've done that. So it's going to create the variables. We're going to create the variables listed in that UML. In case you've forgotten that, it looks something like that. So that's the attributes at the top. So it's going to create the board frame, the square, list of squares list, and it's just going to be empty. The player turn integer to keep track of whose turn it is. Whether the game one, first of all, set to false, obviously, since we have just started the game, and create that instruction label. So that's going to be done. And then we are going to create those board squares. So we actually are going to use nested loops to create a row of labels, and then the nested loops will just move to the next row and create the 3 columns, and then the next row and create the 3 columns, and we'll just use nested loops to do that. And that'll be a call to the square class to actually create that square. As well, in class board, we need to create those accessor methods, for changing return values from class board. So when we're in class square, we want to access a few things that are in class board. We use the accessor methods to get in there, like we discussed. It's good programming practice. So next we move through to the square class, and first of all we're going to create a label. So each square is going to be represented by a label. It has at its heart that label object from tkinter. And we are going to bind to that label a left button click. So that's that button 1. And what it's going to do when it hears that button 1 go off on that object, it's going to call a particular method, and it could call any method that we want. And in this case, we're going to call a method inside that class called square clicked. And we also need to grid that label. So after we've created it, we bind it to a particular method, and then we grid it, which is basically covers where to display it, or how to display it. You can think of it kind of like a pack method. So it allows us to create a grid of labels really easily, which is very useful for this type of game. Okay, so here's my file that I'm going to be using. I'm just going to edit that with idle. And I've chucked a couple of bits and pieces in there. So we've got our main routine. We've created our root window. We've given it a title called Naughts and Crosses. And we've created our first board object. Yeah, we could theoretically create more than one board if we wished. It's made a call to the board class, and it's passed that window as its parent argument. Okay, up here I've defined a class called board. I've started to define the constructor, and above that I've imported all of tkinter, which is important obviously. So let's start coding. So in our initializer, I've just brought up our pseudo code on the right hand side, just to give us a little bit of structure as to where we're going. So first step, we've done these two, kind of given those. We're going to create a frame to hold the game. So we need to give our frame a name. We could call it Frank, we could call it whatever, but it's useful to give it a name that actually kind of resembles what it actually is. So frame equals a frame object. Obviously that's coming from tkinter, and its arguments that it takes are the parent. So what it's actually going to go in. So this frame object is actually going to go in something. Yeah, and it's going to go in that window. Lucky. Now we can also give it some properties, like we can specify the background properties. I had made mine purple, for example. You can too if you wish. You can change that. It's no problem. I won't be offended. If you want to check what options you've got for your frame, or you're actually just a little bit unsure of how to declare it, you're just like, I can't quite remember. So what we can do is we can go to our faithful friend, the internet, and I just type in, say, Python frame, and these tutorials point things are actually quite good, I find. So here you can see it's got two parameters, the master, the parent window, and the options, and then it gives a list of options that we can use. So you can see I use that BG option, the normal background color displayed by the label and indicator. So the frame background color, type of cursor, name, the height of it, all of that kind of stuff, the relief value, the width of it, and you can see it gives you an example down there as well. So frame equals frame, and you can see we have to pack it or grid it afterwards as well, which is what we're going to do next. We're actually going to use that grid function instead of the pack function, but it does same kind of thing but in a slightly different way, and we'll talk more about that as we use it more. So now we're going to grid it. So we're going to do the same kind of thing. We're just going to remind ourselves what Python grid is all about. Tutorial points. Let's have a look. So we've got our widget.grid. So in our case, it'll be our frame object.grid and then the grid options. So you've got column, the column to put the widget in, default equals 0, leftmost column. The row to put the widget in, default will be the first row if it's left empty, and things like that. So they're all useful little options in here. So now that we've created our widget, we need to tell our program how to display it. So that's using that grid concept. So remember the syntax was the object, so that'll be frame1.grid, and then the grid option. So row equals 0, starts at 0, and column equals 0. So yeah, so that's kind of, we've created it here, and we're saying this is how I want you to display it. Yeah, easy peasy. So let's have a look at our code and see what we're doing next. So we've created our frame. Now we need to create the variables listed in the UML. So let's have a look at that UML. So we need to create our board frame. We've done all that. I've called it actually something frame 1. I really maybe shouldn't have done that. Let's call it board frame so it matches up. Board underscore frame. That was rather silly. And board underscore frame. Narrowly avoided a little mistake there as well with the names. So now what I'm going to do is going to create a list of squares equals an empty list, and this is going to be the list that I put my squares into. Not a bad idea as you're going along. List for the square objects to code it. Comment it. Yeah, useful for when you go back to it the next class or after a month or two and you want to kind of have a play around with it again. It's just useful to kind of, oh yeah, that's what I was thinking there. Luckily I commented it. What a great guy I am. So next we're going to do a list. So I've done a list of squares. We're going to do a player turn equals, and we're just going to set that to 0. So evens will be x's and odds will be o's. So evens equal x's turn, possessive apostrophe. Very nice. Okay, so we're just going to churn through these. Okay, so I've done my game 1. I'm going to do my instruction label. I thought I'd bring you guys back into it. So just like I created my frame, yeah, which is a tkinter object, I'm going to create my label, which is also a tkinter object and has, you know, a series of options. Let's just have a little quick reminder. So Python tkinter label. And let's just see what we've got available. So, okay, we make an object, give it a name, and we say it's of type label, and then we've got, oh yeah, what it's going to go into, that's going to be our frame, and then we've got our options. So we've got our background colors, and we've got our anchor positioning tool, and things like that. Fonts, heights, images, justification, padding, all of these things, and the text obviously very important. So we've got all these options that we can play around with. It's quite simple to declare though. So going back, so label. So first was our parent or master. So it's going to go inside that frame. So it's going to be inside board frame, comma, text is going to equal, let's just give it some placeholder text at the moment, placeholder text, and I will come back and tidy that up once I can. We also need to, once we've declared it, obviously just like we did with our frame, we need to say how we're going to display it. Yeah, so we just go now instruction. Now instead of retyping that, I'm just going to copy and paste. It's a much better idea because you ensure that you're not going to make any mistakes when typing in the names of these variables, and that's where we can quite often end up with a few errors. So instruction label dot grid. Okay, we're going to grid this. Now it's going to have to be after our 3x3 grid of squares. So I'm actually going to make it so first will be 0, 1, 2. So this is going to be row 3, comma, column 0, 1, 2, 2. Sorry, 0, 1, and row 1. So okay, let's make that row equals 3, column equals 1. If that went by a little bit fast, it will make sense. Think of the 3x3 square that we're going to create. So we've got row 0, 1, 2, yeah, and column 0, 1, and 2. We're going to put this one below it, so it's going to be 0, 1, 2, and then the button's going to go below it, and it's going to go in our middle column. So that's where I've placed it, just so you know. Okay, I've just realized I've made a little bit of an error, and I wonder if you guys picked it up. All of these objects, lists, integers, booleans, etc., they're perfectly legitimate, they will work. However, they will not be accessible outside of my class, and the reason being is because I have not actually used the self kind of prefix. Yeah. When I use that self prefix, it means that is a part of the object. It's actually a referenceable part of the object. As I dig down into that object, I'm going to find those attributes. Now, sometimes you want an attribute available to be unearthed as somebody digs down into that object, and sometimes you don't. So sometimes you can kind of say, well, this is not going to be available outside of this object. I don't need it available outside the object. I don't need to prefix it with that self dot. But in a lot of cases, we do. And as soon as we do, we need to reference it as self dot. So once I start calling it self dot board frame, I need to reference it further on as self dot board frame. Okay, I'm going to do the same for these ones here. Okay, so these are now attributes of the object. I can access them via the object. When I drill down or dig down into that object, I'm going to come across these. So that's all nice and useful. Now, what I want to do is I'm going to go self dot create what is it actually? Let's go to create board. Create board. That's what I called it. Boom. Okay. Now that is a function call. I'm looking for a method called create board, and I want to run it. Yeah. Now it doesn't exist at the moment. So what we need to do is jump out of our initializer, our constructor, and we're going to define something called. And am I going to type that out again? No. Create board. Remember, all of these things have self as their first argument, parameter. Now that is useful because now I can access all of these variables, these attributes up here. Yep, by being passed self, by that self coming into create board, I can now access this sort of stuff. Give it the full colon, enter. So we're going to use a couple of loops to create our grid. So this is what we're hoping to create on the right hand side here, and you can see it's a 3x3 grid. So one row, 2 row, 3 row. Yeah, and inside each row we have 1 column, 2 column, 3 column. So what we're going to do is we're going to have one loop which is going to take us through each row. Yeah, boom, boom, boom. And inside that that while loop, or that loop, we're going to have another loop which takes us through each column. So it's going to start off with row 1 in our loop, and then it's going to go into our next loop, which is going to take us through our columns, and then we go back to the outside loop. It iterates down to the next row, and then we're back into our inside loop, which is taking us through the columns. Okay, so what that looks like, it's probably a little bit hard to describe in that way, but what it looks like is first of all, we're going to make a variable to store the row. Then I'm going to make a while row is less than, what do we use, 0, 1, 2, less than 3. Do this. Yeah. And we're going to create a column keeper as well. And we need to increment row by 1 each time. Plus equals 1. Alright. So while column is less than 3, do this. See how this is working? So inside the second loop, we are going to create our square object. Yep. So you see the capital S. We kind of know that it's, when we use capitals, we're talking about classes. And then we are going to create a class square. Yeah. So this square object is going to have a series of things that we're going to pass to it. We're going to have to grid each square. Yep, we're going to create the label that's stored inside that square object, and it's going to have to get a grid assignment. So we're going to place it at 0, 0 or 0, 1, 0, 2. And that's going to come from our row and column little variables that we've made here. So square, we need to pass it row, we need to pass it column, we need to pass it self as well. Now the reason we pass it self is so we can access the board from class square. Yeah, we can access the accessor methods, which we're going to write in just a second. Okay, so we need to pass it self in order to get that two-way communication happening. So we've created our square objects. Now we were going to do something with these square objects. What was it that we were going to do? That's right, we were going to store them. We made a list, a special list up here called list of squares. Terrible. Okay, and so we're going to add these into that list just so we can use them to check later on when we're trying to check if we won the game. We can use this to check that fact. Lists are really easy to iterate over. We can move through a list really easily using for loops like we've done before. So that's why we're storing it in there, just for ease of access to these objects so they don't stray. So self dot, because obviously it's got the self in front of it, so we need to refer to it by that moniker, that name. So self.list of squares dot append. I want you to append this object to the end of that list. So chuck it at the end of the list. Really useful little function of list is that append function. So these square objects should now be being put into that list. It's also going to go away and make. It's going to go to class square and start churning out squares. Yep. So it's going to work through those while loops. There's one thing we need to add as well, and that is a column plus equals 1. So we've got our row incrementing. Let me just talk through this. So it's going to go through that while loop because row is equal to 0. So it's going through that while loop, and then it's going down into this while loop and doing this, and it will stay in this while loop 3 times, then it will come back up to this while loop, and then come rows incremented, yeah, and it's coming back into here 3 times. So you can see we've gone for our first row and then created the 3 columns, 1, 2, 3. Then we come back up, we move to the second row, we create the 3 columns, 1, 2, 3, and then we go out and we do our final row down into our columns 1, 2, 3, and then it breaks out of both while loops and we're done. Okay, so that's how that works. So we're now going to jump into class square, and you'll notice that class is all the way to the edge. Yeah, see how it's at the very edge of the window. Indentation is really important in Python. So you see we've got class board, and then our first method, our init method, is 1 indentation space in, everything else is indented inside that, and then we come back in indentation space, and we go create board. It's still inside the class, but it's outside the init, so this is a separate method. But this one, all the way to the edge, because it's a separate class, it's very separate from class board, so that indentation is really important. So we started off in the same way that we start all of our classes off. We go with our init, and we've passed it, obviously we pass it self, that comes. Now that is not to be confused with this self which is being passed up here. Now it's really important to remember that when you're inside a class, you refer to objects of that class type, yeah, of board or of square. They get referred to inside the class as self. It's kind of like how you refer to yourself as self. Yeah, when you're inside your own mind, you don't call yourself your name. You refer to yourself as myself. Okay, but if you were going to refer to a friend, you would call them by their name. Yeah, they're outside of you. They're separate to you, and the same is applicable in classes. So this self actually refers to the object of type square. This self refers to the object of type board. Yeah. But since we're referring to our board object, so let's just get our rows. So let's come in and our column. Now this self has come through from board, so it is a board object. Yeah. It's the board object coming in from class board. Now we don't refer to it as self, obviously, because we're inside class square. We only refer to class to square objects as self. Okay, so let's have a look at our pseudocode. So for square class, we need to create a label at an appropriate size. So we come in here, we're going to go self dot label. What do we call it? Let's have a look at the UML. So self dot square equals our label object. Yeah, and now we need to give it a parent frame that's coming in. So what is it a part of? It's a part of that board object. Yeah. Now I'll tell you what. Instead of referring to board object as it's coming in, we're going to create a variable for use within this class, and we're going to go self.board object equals board object. Okay, so this has now become a variable of the square class. Yep, and it's equal to this board object that's coming in from our board class up here. So now instead of referring to that board object, because I've saved it as a nice local or class variable, I can refer to it like that, which is nice. Keeping it local. Alright, so self.square equals label, and it's got a few options as well. So things like the text that we want it to display. So let's go with blank, like I had before. We can also set things like font. Font equals, say, Arial, size 24. Oops, I almost forgot quote marks. So anything you open, you need to close, including quote marks. That will be the bane of your existence should you forget them. So our square is in there. You can also have a look at setting its size as well, but I'll leave that to you guys. Okay, so that looks to be done. So we've got a, let's have a look, create label at appropriate size. Now we're going to bind that label. So maybe we need a little reminder about what binding's all about. So let's go Python tk label bind. How to bind self events, how to use the bind method. Let's use that. Good gracious. Okay, so it looks like, so there they're creating an entry value, they've gridded it, and they've bound it. So entry.bind, so we should be able to go label.bind, and then the key that we're binding it to, and then the command that we're running, or the method that we're running. So let's have a little try. So where are we? Self.square dot bind, and the button we're binding it to is button 1. And do I need to put that in quotes? Let's have a look. Yes, I do. So button 1. Now the method that you refer to here, it's really important. You'll see that it doesn't have the brackets after it. It's got bind entry. It doesn't have the brackets. So this is just a pointer to the method. You don't want to put the brackets in there. So we're just going to go, we're going to call ours, if we have a look at our UML, square clicked square underscore clicked. Yep, we don't want these brackets in there because that would actually be a function call. Instead of just saying, okay, this is where we go, it would actually run that code. So we just want to leave that like so, and we're pretty happy. So we've created our label, we've bound it to a method. So we've created our label. What do we do with the next? I can't really remember. Let's have a look up here. So we've created our label, and we now need to, oh yeah, that's right, we need to say, okay, this is how you display it. So self.square.grid, and I want you to display it in the row that's been passed in to the initializer. Yeah, and the column. So actually, row equals row. Yeah. That could get confusing. Let's change this. Row position. Row equals row position. Col position. Column equals col position. Okay, so that should be sweet. Just tidy that up because it could be a little confusing with the naming. I think that should be good though. Okay, I'm just going to chuck pass in here because we're not actually going to go through and define the square clicked thing just yet. We're going to just get it displaying, and then we'll be happy with that as a first stage. Now, I tried to run my code and I have to confess that there are a few errors, so I'm just going to tidy up some errors, like for instance that shouldn't be out there, and oh my goodness, I forgot a comma there, and self.board object. I need to actually dig a little deeper and go into that board object and look for that board frame. So that should be board frame because that's the actual frame that I'm putting it in. What else was at issue? Oh yes, append square. I need to, let's have a little let's just try that. Yeah, that's alright. This square click though needs to be self.square clicked. We refer to things by using our internal object. Also, a little mistake, like that should have a hyphen in there. I believe that's all the errors. Let's just have a little test run. So let's check this out. So we're still getting an error. So what I usually do when I'm getting an error is I read from the bottom. As you can see, traceback, most recent call last. So line 18 in init self.instruction underscore label board frame comma text placeholder text. I think I need to refer to it. Yeah, the board frame's not defined. I think I need to chuck a self in there. So that self instruction label, a little bit of an error there. So that should be self.boardFrame. Let's try that. Okay, so there I'm getting my blank labels. Now, they're not really displaying as I wanted. I would like them a little bit spaced out. And there is a little useful function that we can do up here. We can set the minimum column width. So I'm going to go ahead and do that. Okay, so what I've done is I've just made a for loop. So for I in the range up to 3, I'm going to, for self, boardFrame.column configure. Yeah. Column I, yeah, which will start obviously 0, 1, and then 2. So column 0, I want that min size at 150. Rolling through the for loop. Column 1, I want that min size at 150. And then column 2, obviously min size at 150. So that should alleviate that problem somewhat. And you can see they're a little bit spaced out. And what I can do to get a little bit of space between them is I can play around with the label padding, and that will help us out. So I leave that up to you intelligent people to sort out the display a little bit. Okay, so we've actually achieved quite a bit. We've got our frame being created. We've got that setting, a few settings in there. So we create the frame, we grid it, so create the widget and then how it's displayed. Empty list for those squares that we're creating down here. We've got our attributes from our UML diagrams there and there. We still haven't created our accessor methods, which we will use in this square clicked thing of class square, but we can do that in a bit. We've got this displaying, and that's a pretty big achievement. So the things that we've covered, the planning, the UML diagrams, obviously, and we also covered a little bit with our pseudo code. That was quite useful. We used that. And I hope you've learned a few things. I hope you can see how we can plan and execute that plan for our programs, whatever they may be, in this case a game. And we've learned a bit about how widgets work from tkinter, and a little bit about while loops or for loops, or whatever you may have picked up along the way. So we are now moving on to part 2, which will cover how we get the functionality of the game. That's mainly oriented around the square clicked business.